All right, so here's our second video on how to determine one-sided continuity using graphs. Let's take a look at the question here. The question is asking, is f of x, is our function, continuous from the right at x equal to 6? All right, now, why did I emphasize the 6? That's because the graph emphasizes continuity here at x equal to 2, but that's not what we're being asked for. We're being asked to find continuity from the right side of the function at x equals 6. So we need to shift our eyes over to where the function is when x is equal to positive 6. All right, so I'm going to go up and I'm going to find, hey, that function is actually defined at that point, right? When x is 6, we have an output, so it is defined. And we're focusing on the continuity coming from the right side. So we're only going to focus on the direction coming from the right. All right, so let's begin. We want to first identify, is f of a, is it defined when x is equal to a? In this case, x is equal to 6. So do we have an output for f of 6? This would be part 1 of our definition of continuity, and it looks like we do. We have an output, it is defined. The output would be 4. All right, the limit doesn't exist coming from the right. So let's take a look. Part 2, the limit as x approaches 6 from the right side. What is that? Well, as we're approaching from the right side, what is the intended height? It looks like the intended height is also going to be 4. So looks like the output and the limit approaching from the right agree. So therefore, when we check for part 3, is f of 6 equal to the limit as x approaches 6 from the right side of f of x, right? Both of these are equal to 4. So in that case, we satisfy all 3 parts. Therefore, we get to say that f of x is continuous from the right at x equal to 6, or you could indicate yes on your IXL skill.